Hello, students. In this lesson, we're going to learn about series and parallel circuits. These are fundamental concepts in electrical engineering, and the link will be provided. So once you get on this link, click on the series and parallel circuits lesson. Let that load up. In this tutorial, we'll learn about two fundamental types of circuits, series and parallel circuits, and find out how to apply them to most efficiently light up multiple LEDs, because more lights equals more fun. So here's an example of what we're going to end up doing. And we have several circuits already created in our workspace for us. Go ahead and click next. A series circuit. So we're going to start off with series circuits. So let's say we have a circuit with a single LED as shown in the leftmost circuit in the editor right here. But we now want to be able to light up more than one light. Your first thought may be to add another LED directly to the circuit, chaining it to the existing LED as shown in the middle circuit, which is right here. So that's your first thought, right? This configuration is known as a series circuit, and where there is single path for current to flow. So this is a series circuit. The current flows from the positive side of the battery to the negative side, and thus the amount of current through each component is the same. We're also using a new tool called a multimeter that lets us measure voltage, current, and resistance in the circuit. Now, before we do anything else here, I'm going to show you what a series circuit looks like. This is a series circuit, but in my opinion, having these multimeters in here kind of makes it a little more confusing. So I'm going to quickly create a series circuit and demonstrate what that might look like. Let me get a switch to. Okay, so I'm going to go from, I'll put this here, switch up here. There we go. And so we're going from positive make this all green or red. Okay, so if I start simulation, the LED is on. Okay, this is on off, right? Okay, so it's on. Let me decrease this resistance a little bit so that LED is a little bit brighter. Okay, so this is a series circuit. We're going from positive through, so from the positive end of the battery through the wire, through the switch, through the wire, through the resistor, through the LED anode, out the cathode, and to the negative. So this is a series circuit. Okay, so it's one path. There's one path for current to flow, and that's the key concept for a series circuit. Okay, so now that I have a little example over here, now maybe this will make a little bit more sense on this set, because we do have a multimeter and a voltmeter in here. Okay, so it says start the simulator. Notice how with the middle circuit, let's zoom out. Okay, it says notice how with the middle circuit the LEDs seem to be barely on, so we can barely see them on. This is because LEDs have a forward voltage typically around 2 volts. If we have two LEDs requiring 2 volts, that's a total voltage drop of 4 volts, which is greater than our current 3 volts that the battery can supply, which is right here. This is a 3-volt battery. Check out the multimeter readings. The voltage from the battery is currently being split across the two LEDs. So 1.5 is being split across this LED. If I put this voltmeter right here, you'll see it at 1.5. So the 3 volts is getting split across both of the LEDs. So hopefully that makes sense. So 3 volts going in, LED 1 is taking 1.5 volts, LED 2 is taking another 1.5 volts, and back through. So the voltage from the battery is currently being split across the two LEDs, providing only 1.5 volts each when they require 2 volts to light up. This is why there is no current flowing through the circuit. We're going to continue to the next step where we'll see how we can rearrange the LEDs in a parallel configuration to solve this problem. Next. In the rightmost circuit, zoom out, we have a parallel circuit. Notice how each LED has one leg that has a path to the negative side of the battery and another that has a path to the positive side of the battery. So we have, see how they're all connecting to the negative right here? So from the negative side of the battery, they're going to the resistor through the LED, to the resistor through the LED, and so on. So this is a parallel circuit. Okay? So it's kind of like cycling the voltage. The current is going in, through each one, and you should get a voltage across each one that's the same. So when the components are arranged in this way, the current from the battery splits into each of these paths, while the voltage across each LED is the same. Okay, so we're going to start the simulation. It says, let's measure voltage across any of the LEDs using a multimeter. Add a multimeter, so let's find the multimeter in the components menu. Okay, so that's this right here, so I'm going to drag that up here. And it says connect one leg of the multimeter to one side of the left leg of an LED and the other to the right leg. Okay, so let's do that. So we're going to click, try and keep it all organized at the top here. I'm going to click here and connect it to there. Click here and connect it to the anode right there. Now it says make sure that the multimeter is set to measure voltage by clicking the V. Okay, we're in the voltage mode. Start the simulation and see how much voltage has dropped across the LED and how does this voltage compare to that in the series circuit. So start simulation. So that's 2 volts. 2 volts is going across this LED compared to the 1.5 volts. Okay, so that if I were to take the multimeter and measure from here, oops, come on, connect, there we go. Let me try that again. I pressed escape. Okay, and then to here. Should get the same reading, 1.99 volts. That's because it's in parallel. So the current is flowing through here in a parallel circuit. Continue. So you've learned about some of the basic differences between series and parallel circuits, as well as how to effectively and safely power multiple LEDs. Okay, so practice hooking up LEDs in parallel by adding additional LEDs to the parallel circuit. So let's do that. So I'm going to stop simulation. I'm going to go ahead and delete this. I'm going to delete this one too. Okay. And what we can do is just go boop, boop, boop. Add a wire. Okay, now we're going to add another wire up here. Okay, I got to actually add a component first. My bad. So clicking our resistor. Let's rotate that. How much of the resistance is this? This is 60 ohms. Okay, let's try and match that. 60 ohms. Grab an LED. Connect those two. Click on the negative side of the battery. Connect it to the resistor. Connect the positive. Okay, and now click start simulation. They should all light up the same. Okay, so that's what a parallel circuit is. All right, make sure you complete the assignment directions as instructed in your Google Classroom and keep on Tinkercading.